Hello and welcome back to Engineers Olympiad, where learning meets success. We're doing the numericals of the first chapter, Introduction and Basic Concepts of Surveying. So let's begin. Question is, design a direct vernier for a theodolite circle having main scale graduations up to 20 minutes if the least count is 20 seconds. As we know, least count is equal to S by N, where S is the smallest division on the main scale and N are the number of the divisions on the vernier scale. In this case, it's given that least count is 20 seconds. So least count is 20 seconds. What is my S? Design a direct vernier for a theodolite circle having main scale graduations up to 20 minutes. So my S is 20 minutes. I'll convert it into seconds. And N are the number of the divisions on the vernier scale which we have to count. By calculations, my N will come equivalent to 60. That means I need 60 divisions on the vernier scale. We have to design a direct vernier. As we know that in a direct vernier, each number of divisions on the vernier scale equal to N minus 1 divisions on the main scale. That means 60 divisions will correspond to 59 divisions on the main scale, right? So, vernier will be devised in this case, in which will be having 59 divisions of the main scale will correspond to 60 divisions of the vernier scale. In this question, 59 divisions of the main scale will correspond to 60 divisions of the vernier scale to form a direct vernier in this case, because as we know, in a direct vernier, N divisions of the main scale correspond to N divisions on the vernier scale correspond to N minus 1 divisions on the main scale. So we design the direct vernier. Let's do the next question. Question is, a Philadelphia rod has the main scale graduations in centimeters. Design a suitable retrograde vernier to read up to 1 mm. To read up to 1 mm. The question is, a Philadelphia rod has the main graduations in centimeters. Design a retrograde vernier to read up to 1 mm. What is a retrograde vernier? A retrograde vernier is a vernier in which N divisions of the vernier scale correspond to N plus 1 divisions of the main scale. So we have to design a retrograde vernier in this case. So least count, as we know, is equal to S by N. Least count is given. We have to design a retrograde vernier such that it may read up to 1 mm. That means its least count is 1 mm. What is least count? Least count of the instrument is the smallest reading that it can take. It can measure. So 1, what is my S? A Philadelphia rod has the main scale graduation in centimeters. If S is in centimeters, for example, say 1 centimeter, least count is 1 mm. So we'll convert centimeter into mm. It will be 10, and my N will come equal to 10. So number of divisions on the vernier scale came out equivalent to 10. Retrograde vernier. That means 10 divisions of the vernier should be equal to 11 divisions on the main scale. 10 divisions on the vernier scale will be equivalent to 11 divisions on the main scale, and hence we designed a retrograde vernier for this Philadelphia rod. Move on. Let's do the next question. Next question is a box sextant. A box sextant has the mean scale readings in a box sextant has the mean scale readings in 10-minute graduations if the least count desired for an extended vernier is 10 seconds. How much? 10 seconds. Design an extended vernier. We have to design an extended vernier for this case. Right? So the question is, a box sextant has the main scale readings in 10-minute graduations. If the least count desired for the extended vernier is 10 seconds, design an extended vernier. As we know, in an extended vernier, n divisions of the vernier scale correspond to 2n minus 1 divisions of the main scale. Right? In an extended vernier, n divisions on the vernier scale correspond to 2n minus 1 divisions on the main scale. We have to design an extended vernier in this case for a box sextant, and we know least count is equal to S by n. What is the least count? It's given that if the least count desired, they are deciding that the least count for the extended vernier for this box count should be equal to 10 seconds. What is my S? A box sextant has the main scale readings in 10 minutes. So my S is 10. I'll convert it into seconds for dimensional homogeneity divided by n. My n will be equal to 60. Right? My n is equal to 60. So n divisions will be on this vernier scale. That means 60 divisions will be on the vernier scale. So how many divisions do I require on the main scale? Since it's an extended vernier and n divisions on the vernier scale correspond to 2n minus 1 divisions on the main scale, which is equal to. So how many divisions do I require on my main scale? 190. So I designed a retrograde vernier for this box sextant, extended vernier for this box sextant, in which 60 vernier divisions will correspond to 119 divisions on the main scale. Right? Moving on, let's do the next one. Next question is, design a direct vernier to read to 1 minute. On the main scale graduated at 30 minutes. graduated at 30 minutes. Right? So the question is, design a direct vernier to read up to 1 minute on the main scale graduated at 30 minutes. Let's solve this. We know that least count is equal to S by N. What is my least count? Design a direct vernier to read up to 1 minute. My least count is 1. What is my S? 30. That means my N will come equivalent to 30. So how shall I design a direct vernier in this case? In this case, 30 divisions of the vernier scale will be equal to 29 divisions on the main scale. This will be a direct vernier for this case, in which 30 vernier divisions will correspond to 29 divisions on the main scale. Let's do the next question. Next question is, design a suitable retrograde vernier design a suitable retrograde vernier to read up to 0.5 mm. If the main scale has graduations at every 5 mm. So the question is, design a suitable retrograde vernier to read up to 0.5 mm if the main scale has graduations at every 5 mm. Let's try to solve it. We know that least count is equal to S by N. We have to design a retrograde vernier, and in a retrograde vernier, N divisions on the vernier scale correspond to N plus 1 divisions on the main scale. Let's try to find the least count first. Least count has been desired. It should read up to 0.5 mm. So 0.5 is equal to, what is my S? It has graduations at every 5 mm. So my S is 5. From this, my N will be equivalent to 10. Therefore, 10 divisions of the vernier scale should be equal to 11 divisions on the main scale. 10 divisions of the vernier scale will be equivalent to 11 divisions on the main scale to form a retrograde vernier in this case. Right? Let's solve another one. Question is, design a vernier for a theodolite circle design a vernier for a theodolite circle divided into degrees and half degrees to read up to how much? 30 seconds. So the question is, design a vernier for a theodolite circle divided into degrees and half degrees to read up to 30 seconds. So let's solve this. We know that our least count is equal to S by N. They are desiring that the least count should be 30 seconds. What is my S? Design a vernier for a theodolite circle divided into degrees and half degrees. That means smallest division on the main scale is half degree, and half degree is how many minutes? 30 minutes. But for dimensional homogeneity, we convert it into seconds. By that, my N will be equal to 60. So, number of divisions as required on the vernier scale is 60. So, 60 divisions of the vernier scale should correspond to 59 divisions on the main scale. 60 divisions on the vernier scale will correspond to 59 divisions on the main scale for direct vernier. Right? Circle was divided into degrees and half degrees. That means our S was 30 minutes, which we converted into seconds, and we designed a direct vernier for this case, in which 60 vernier scale divisions will correspond to 59 divisions on the main scale. Let's do the other question. Next one is, design a vernier for a theodolite circle. Design a vernier for a theodolite circle divided into degrees and 1/3 degrees. To read up to 20 seconds. Right? So my question is, design a vernier for a theodolite circle divided into degrees and 1/3 degrees to read up to 20 seconds. As we know, least count is equal to S by N. What is my least count? They are desiring that it should be 20 seconds. What is my S? Smallest division on the main scale. A vernier, we have to design a vernier for a theodolite circle which is divided into degrees and 1/3 of a degree. How much is 1/3 of a degree? 20 minutes. We'll convert it into seconds and our N will come equivalent to 60. Right? So 59 divisions should be taken for the length of the vernier scale and divided into 60 parts for a direct vernier. So 59 divisions on the main scale will correspond to 60 divisions on the vernier scale, and hence we have designed a direct vernier in this case, in which 59 divisions should be taken for the length of the vernier scale and divided into 60 parts for the direct vernier. Right? Let's do another question. Okay, so the next question is, dividing the smallest division of circle. The value of smallest division of a circle of a repeating theodolite is 10 minutes. Design a suitable vernier to read up to 10 seconds. Design a suitable vernier to read up to 10 seconds, right? So what is my question? The value of smallest division of a circle of a repeating theodolite is 10 minutes. Design a suitable vernier to read up to 10 seconds. Okay. Least count is S by N. What is my least count? They are desiring that it should read up to 10 seconds. So my least count is 10 seconds. What is my S? The value of smallest division of a circle of a repeating theodolite is 10 minutes. The value of smallest division of a circle, right? So that is S. S is the smallest division on the main scale, and that in this case is 10 minutes, but we'll convert it into seconds, and my N will be equal to 60. So we'll take 59 such primary divisions from the main scale and divide it into 60 parts of the vernier scale. That means 59 divisions on the main scale will correspond to 60 divisions on the vernier scale, and hence the direct vernier for this repeating theodolite is designed. Right? We'll take 59 such primary divisions from the scale and divide it into 60 parts for the vernier scale. Let's do another question. We're trying to solve as many numericals as possible. The circle of a theodolite is divided into degrees and 1/4 of a degree. Design a suitable decimal vernier to read up to 0.005 degrees. Design a suitable decimal vernier to read up to 0.005 degrees. So the question is, the circle of a theodolite is divided into degrees and 1/4 of degree. Design a suitable decimal vernier to read up to 0.005 degrees. What is my least count? S by N. What is the least count that they are desiring that this theodolite should have? It should read up to 0.005 degrees, which makes its least count. What is my S? The circle of a theodolite is divided into degrees and 1/4 of a degree. So S, the smallest division in the main scale, is 1/4 of a degree, right? And N are my number of divisions on the main scale. By calculations, my N will be equal to how much? 50. My N is equal to 50. That means 50 divisions of the vernier scale will correspond to 49 divisions of the main scale. 50 divisions of the vernier scale will correspond to 49 divisions of the main scale to form a direct vernier for this theodolite. Right? Let's do another question. As I already told, I'm trying to solve as many questions as possible. It gives a better insight into the subject and the concept. All right, let's move on. Next question is design an extended vernier for an ebony level. So it must also be noted that an ebony level has an extended vernier. Design an extended vernier for an ebony level to read up to 10 minutes. The main scale is divided into degrees. So the question is design an extended vernier for an ebony level to read up to 10 minutes. The main scale is divided into degrees. My least count is equal to S by N. My least count desired is 10 minutes. What is my S? The main scale is divided into degrees. That means my S is 1 degree and 1 degree is how many minutes? 60. So my N will be equal to how much? 6. So I need 6 divisions of the vernier scale. Now since I have to design an extended vernier, and as already told, in an extended vernier, N divisions on the vernier scale correspond to 2n minus 1 divisions on the main scale. That means how many divisions do I need on the main scale? Right? So I need 11 divisions on the main scale. So 6 divisions on the vernier scale will correspond to 11 divisions on the main scale to form an extended vernier for this ebony level. Right? 11 divisions of the main scale will form 6 divisions of the vernier. Let's do another question. So next question is, the circle of theodolite is graduated to read 10 minutes. Design a suitable vernier to read 10 seconds. I think we did this. I think so. Or even if we did, let's do it again. The circle of a theodolite is graduated. The circle of a theodolite is graduated to read 10 minutes. Design a suitable vernier to read 10 seconds. The question is, the circle of a theodolite is graduated to read 10 minutes. We have to design a suitable vernier to read 10 seconds. What is my least count? S by N. What is my least count? 10 seconds. What is my S? It has been graduated in such a way that the smallest division is 10 minutes. It can read up to 10 minutes. That means my S is 10, but I'll convert it into seconds. So my N will be equal to 60. Therefore, 59 divisions on the main scale will correspond to 60 divisions on the vernier scale to form a direct vernier for this theodolite. 60 divisions on the vernier scale will correspond to 59 divisions on the main scale to form a direct vernier for this theodolite. Right? Let's do another question.